We bundle up with coats and hats in the winter, but Arctic mammals, like seals, swim comfortably in freezing water. How are they able to stay warm in such extreme temperatures? We can easily investigate this phenomenon using the PASCO wireless temperature sensor link. The wireless temperature sensor link comes with our fast response temperature probe and is powered by a replaceable coin cell battery that is included. The sensor is compatible with many different PASCO products, including probes like the surface temperature probe, stainless steel temperature probe, and even physics equipment like this thermal expansion apparatus. The fast response temperature probe that the sensor ships with is a lightweight, low thermal mass probe, ideal for recording quick temperature changes. The wireless temperature link sensor connects wirelessly to computing devices via Bluetooth, so you can easily use it with PASCO data collection software like SparkView, Capstone, or ChemView. I've already connected this sensor in SparkView and plugged in a fast response temperature probe, so we're ready to investigate. We have our beaker of ice water to simulate Arctic water temperatures. I'll start collecting data and then add the probe to the ice water until it reaches thermal equilibrium. We can see that the probe alone quickly cools down. It takes about 5 to 10 seconds to reach the same temperature as the water. You can see that if I move the probe, it senses the minute temperature differences within the beaker. Near the edge of the beaker is warmer, and in the center is colder. It responds quickly to fluctuations in temperature. Now we can remove and dry the probe and swap it for a different room temperature probe encased in shortening to simulate fat or blubber in Arctic mammals. In a classroom setting, students can use the same probe after it has reached room temperature. I'll start recording data for our second run and then place the probe and shortening into ice water. You can see in the first few seconds that the probe and shortening is cooling at a much slower rate than in the first run. The temperature continues to decrease, but the rate of change is small. We can see that the probe with the shortening cooled at a much slower rate than the probe without insulation. In a similar manner, Arctic marine mammals use their blubber to retain body heat and conserve energy in freezing cold water. Visit the experiment library at pasco.com to find investigations you can do with the wireless temperature sensor link, like testing the energy content of food or homeostasis. Thanks for watching.